So let's talk about the concept of a learning rate. So as we've seen, a learning curve assumes that the more times we repeat a task, the better we become at it, the less time we'll take at performing the task, and the less cost a business will incur if its workers become better at a task, right? Now, the premise behind that is there's something called a learning rate. And what the learning rate says is that every time that you double your output, so every time output doubles, the cumulative average time or cost goes down by a particular percentage. Okay, now what does this mean? Because we need to be careful, it's a very specific definition. What that means is, let's say you produced 1 unit and it took you 100 hours to produce. Okay, and let's say your learning rate is 80%. What that means is when your output doubles to 2, the cumulative average time goes down by 20%. In other words, it becomes 100 less 20%, 80, or 100 into 80%, right? So what we're saying is that the first unit took 100 hours to produce, the first 2 units, including this one, took 80 hours to produce. In other words, the second unit took 60 hours, the first unit took 100 hours, 160 in total, divide that by 2, you get 80, right? Likewise, if the learning rate was 90%, for example, that means if the first unit took 100 hours to produce, the first 2 units on average took 90 hours to produce, meaning the second unit took 80 hours plus 100 of the first, 180 divided by 2, we get this average 90. Okay? Now, this is important because a lot of people mistake that the learning rate implies the rate of learning or how quickly we learn. That's not the case. As you can see, the lower learning rate of 80% means we're doing work faster. We're doing it in less time as compared to the higher learning rate of 90%, right? So what that means is a lower learning rate is better, okay? Now, when it comes to learning rates, there's certain things we need to know. First of all, what causes the pace of learning to increase or decrease? There are certain conditions that can cause it to increase or decrease. So, first of all, if the work is of a repetitive nature, you're doing the same thing over and over again, you learn faster. Think back to school. Every time they wanted you to learn a new math concept, they'll have you do one after another question, right? Keep repeating questions until you get the hang of it. So if you do the same type of question over and over again, you become better at it. But if the nature of work is constantly changing, you're doing something new every time. So the workers designed a different one type of product, then they went to a completely different type of product. So they went from a sweater to a semiconductor chip to a bottle of water. They're doing all these different tasks. They're not going to get better at any one specific task or product, right? So that'll slow down the learning. Second, continuous production runs, doing it over and over again in quick succession. So you did the questions in school one after another. You didn't do a question, waited for 1 month, did another question, right? If you take breaks between the work, you'll forget what you learned and have to start all over again. Then the same workers working on the same areas, specialization, right? If you work on the same task over and over again, that's how you get better. That's why there's workers in the accounts department, workers in the sales department, right? Workers in the production department, so that they can become better at their job rather than changing the work that they do. Low staff turnover. Staff turnover meaning how quickly people leave, right? So if you have low staff turnover, it means the company has the same people sticking around for a long time. So they'll become familiar with the company, its operations, its products, and become better at their job, therefore learning faster, as opposed to high staff turnover, that every few months there's a new worker coming in and he has to learn from scratch and catch up to what the previous worker would have been doing, right? So that slows down learning. Uniformity of products and design, right? If the process is simple, the workers are doing the same thing over and over again, making the same types of products, that's what is conducive to learning, as opposed to constantly changing products and designs. But it's not just about the rate of learning. There's also the amount of learning we need to consider, which has to do with the steepness of the learning curve. Remember, the learning curve was shaped like this, right? So the steepness meaning like this. If it's a steep learning curve, you're learning all this amount, right? You're learning a lot. So when does that happen? One, if the process is labor intensive as opposed to capital intensive. Workers have a lot to learn, right? Workers, human beings get better. Computers and machines don't learn or become faster at their job, they just do it at a constant rate. Secondly, complexity. If it's a complex task, so think about it this way. Where did you learn more? When you learned simple addition like 2 plus 2 is equal to 4, or where you learned something like learning curves or activity-based costing? Obviously, you learned more in the more complex topics, right? Same with work. If you're dealing with something of a more complex nature, you learn more as opposed to something simplistic, right? Finally, whenever there's new work to do, you'll learn more. New products as opposed to old products. So once you've gotten used to the old product, you've already reached your steady state, you can't get any better. And then a new product comes in, so you learn more. That's how what workers do, right? They want new experience. They want to work on a different project, a different product. That's how they learn more and grow more, okay? So those are some of the key things we need to know about learning rates. What affects the pace of learning, what affects the amount of learning, and the fact that a lower learning rate is technically better.